Okay, 11.4, alternative energy sources. Our objectives for this lesson, we're going to describe both passive and active methods of harnessing energy from the sun. We're going to explain how geothermal energy may be used as a substitute for fossil fuels. And then we're going to discuss how hydroelectric energy and wind energy are used as alternative energy sources. So let's get started. All right. So first of all, let's talk about solar energy. Here's the deal. Our sun is the ultimate power of all energy. We receive so much energy from the sun, it's not funny. Every 15 minutes, we receive enough energy to power the entire world for a year. And we have yet to quite figure out how to harness that. The moment that we figure out how to harness it, the moment that we will become completely independent of all fossil fuels. So the first thing we're going to talk about is types of solar energy systems. The first one is a passive energy system. Passive means exactly what we're talking about. It's laid back. It's just soaking it up. You know that there are people out there who are very passive, and you know there are people out there who are very active. Probably can't tell which one I am. But the passive one, the one that's sitting back, is like this particular house right here. Now, I want to explain. I set up my house this exact same way, and I'll explain it as we go. All right, so this particular house here in the diagram, we're looking at a house that has a southeastern exposure. The reason why we do that is we are letting the sun take its natural path as it is in our sky as we go around the sun, the natural path that it takes place in our sky. And as it does, it gives us exposure during the parts of the day to where in the evening, towards about 2 o'clock, the sun starts to get blocked by the side of our house. Now, this passive solar system has no moving parts. All we're doing is we're taking advantage of the sun coming in the windows, heating up the floor space, and then radiating into the room. Now, to explain this, I'll make it easy. In the summertime, the sun is higher in the sky because it's over the tropic, and as it's doing that, it's not able to go inside the window if we have a large enough eaves or an eave, and what that is a overhang of our roof. So when we talk about this on my house, I have about a meter overhang of my roof to where the sun, when it comes down in the summertime, is blocked from this particular window right here. Now in the wintertime, when it's at the other tropic, the sun's at the other tropic, it's low on the horizon, and so what happens is it's able to have the solar rays directly come in through the window. Now, I'm sure you've all experienced this with a candy bar in the front of your car or something. You have a candy bar in a car, call it a Milky Way, a Snickers, I don't care. You have it in the window, and then what happens is the sun's infrared radiation warms up the Snicker bar in the window, and it causes it to melt, this giant puddle of goo, right? So as it's doing that, what's happening is the infrared radiation is causing this space in here to heat up. As it does, it radiates into the air, right? It causes it to get warmer. Now, you have to have material in front of the windows. So in my house, I have tile floors and wood in front of all of the windows. And the reason why I do that is they are going to hold the heat in the room. It's amazing how it helps reduce the impact of the cold weather, but also reduces our bills because I don't have to heat up the house as much. And so now my room is warmer, cooler in the summertime because the cold, if you ever walk on tile, it's cold. And if in the summertime it's cold, that keeps our house nice and cold. So this is a passive system for a house. Laid back, just soaking it up, taking it all in. Exciting. Let's go to the next system. Active. An active solar system uses a solar collector of some sort. And as it does, what happens is it's transferring a liquid or a fluid after it's been collected. And pretty much it's something like sodium glycol or whatever, but what ends up happening is it's not water because water freezes in the winter time. Makes sense. So now we have this fluid, this antifreeze type fluid flowing through the solar collectors. As it does, a pump, the active part of this, a pump moves that fluid through. As it does, it goes to our hot water heater, our boiler, if you will, and you can do a couple of things. You can use this to heat your hot water. You can use this to heat your floors, because what they do is they run water, these lines through, and they're not water, they're sodium glycol, but these lines through your floor and underneath, and it naturally radiates and warms up your floor. Now the thing that you have to do is you have to be able to shut this off, because in the summertime you don't want hot floors, you want cold floors. Now here's the other thing that can happen is photovoltaic cells, right? Photovoltaic cells. So like the rooftop solar panels that are powering this classroom, our classroom, those are photovoltaic cells. A little bit different, not any moving parts. We are just using photons of energy to excite the electrons within the photocollector, within the photocell, to create a differential, to create energy. And so great opportunity to provide energy to us either in heat or in electricity. Now, here's what I want you to do. I want you to stop this VOD, push pause, and when you do, I want you to play the SciShow solar energy clip and the photovoltaics energy clip on your Moodle page. And when we get back, I'll pick up from there. Okay, you're back. This is exciting. So we're going to move on from passive and active and move on to geothermal. Geothermal means just that, using the temperature of the earth to create energy. And so what's happening is we have water that's in our crust, and it's being heated by magma. And the magma, or regional metamorphism, the regional heat that's in our area, can create a hot water source which produces steam. And again, no different than if you're using nuclear power, or you're using fossil fuels. No matter, you create steam in geothermal energy. And that steam then turns a turbine and directly generates electricity. Now, interestingly enough, 80% of Iceland's homes are heated by geothermal energy. Their heating needs all clean, no need for any sort of heating elements in their home. It's all clean. That is so cool. What's the problem? Why can't we do that in Illinois? Well, we don't have geothermal energy in the form of magma coming to the surface, but what we do have is another type of geothermal energy. What I want you to do, stop the VOD and click on Modern Marvels Geothermal Energy in Iceland, and then when you're done with that, come on back and we'll pick it up. Okay, you're back. All right, so that's geothermal energy in magma or igneous rock, right? But now let's talk about geothermal energy here in Pontiac, Illinois. right? So our home, this would simulate our home, or better yet, our school, because our school uses this type of energy. But basically what you've done is you've dropped a water line, or in this case it's not water, but it's something like sodium glycol, and you run these lines, this loop of lines. Now, here's the neat thing. After you get to a certain depth, our ground pretty much stays the same temperature, which is about 52 to 58 degrees Celsius or Fahrenheit if there's no magma intrusion, or you're not getting into the deep bedrock. So it stays around 52 to 58 degrees Fahrenheit. Now, how does this work? Well, this works really interesting. What happens is we're using in the winter time, so in the winter time, let's say it's 0 or 32 or whatever temperature it is, we're piping this liquid down into the earth to a point where all of a sudden it starts to become about 52 to 58. Now, instead of heating your home from 0 or 32 or whatever it is, now we're heating it from 58. So we're using the ground to give us a jump start. So we're getting full steam ahead, if you will. We're getting this extra boost. This boost to where now all you have to do heat up is from 50 to, like in my house, 68. So maybe 10 degrees, 58 to 68. Or some of you who have warmer homes, 70, 71 in the wintertime, degrees Fahrenheit. But in the summertime, this works great because you can do the exact same thing, only you throw it in reverse, or even throw it the same way. So we pump out water that's at room temperature, 70 degrees Fahrenheit, 80 degrees Fahrenheit. Then it goes into the ground, and then it tries to acclimate to that 52 to 58. All of a sudden, we now have cold energy, and we don't have to put anything but the pump mechanism into it. And so this is where geothermal energy in homes really shine. It's an excellent example of how we can use it in the summertime, or we can use it in the wintertime and power our needs for heat. Right? So what I want you to do is go ahead and stop the VOD at this time, and I want you to watch Home Geothermal. That's the next one. When you're done, I want you to come back and we'll pick up where we left off. Okay, you're back. All right, I hope you enjoyed that. Now we're going to move on to the next one, which is the energy from wind and water. And basically what we're going to talk about is using a turbine from powered by the wind or water to generate energy. Now, this is really cool and really awesome because it really hits home, especially with wind power. And we'll talk about that at great length. Now, energy from running water, how does it work? Well, we're using potential and kinetic energy. We've got the potential energy of all the water stored behind this dam. We've basically dammed up this stream, river, lake, whatever, this reservoir, and we have water that's going to flow. As it flows, it turns a turbine. It turns the turbine, creates electricity, and the electricity goes on. Now, here's what I will tell you. I grew up on a lake during my middle years, so middle school to high school, down in Arkansas, and it was dammed up. A dammed lake provides a lot of things. Recreation, swimming, boating, skiing, scuba diving, doesn't matter. But it does change the landscape. So if you look, this river that's going through here might have only been a river through here, now it's a lake. And so all of that land is now underwater. So there is some controversy associated with that type of thing because it changes the landscape and the organisms that can live there. Ultimately, only 11% of the U.S. is powered by hydroelectric power. That said, we are getting into systems called microhydro. And microhydro is a way that people can generate electricity for their homes if they have nearby running water. And there's opportunities where you don't have to have such this huge operation. But you have to have running water. How does running water work? Hydrologic cycle. It rains. You dam up the rain. All of a sudden you unplug the dam. Away you go. Very, very cool. Very cool. I actually watched a story about an island nation that had a dormant volcano on it, and they were trying to figure out how to get 100% of their energy needs from met on the island from renewable energies. And so basically what happened was they figured out that they could use the volcano as a battery. And I know that makes a really weird statement, but here's what they did. They used solar panels during the day to pump water into a volcano, and then they were able to capture the water. And then at nighttime, when the sun wasn't out, they then used the volcano's running water as they opened up the turbine to power the electricity during the night. So they had solar energy in the day, water from the water they had put up to the top of the volcano in the nighttime, and they had 100% of their energy needs met. How stinking cool is that? That is amazing. Now, energy from the tides. And I don't have a picture on here, but basically what happens is you have a wave that comes in and it moves a plunger, and when the plunger moves, it turns a turbine. Or you let the water flow in, and the tide then comes up to a certain reservoir, fills behind the reservoir, they dam it off, let the tide flow out, and then open it up and it turns a turbine. These are two great ways for that to happen. That's not a lot of energy needs, but if they could figure it out, what can happen is this happens twice a day, every day, on every coast where there is water. And that works. So all of these things together really give us great opportunities. All right, so I want you to hit pause or stop. I want you to watch hydroelectric power. And then what I want you to do is come back when you're done. Okay, hit stop. Okay, you're back. Exciting. Let's go on to wind energy. Wind energy. This is what happens here in our area, right? The wind blows and it's pushing on the propeller. And due to Bernoulli's principle, it's pushing the propeller around in a circle, which is on a generator, and the generator then powers the turbine, or powers the electrical grid, and away we go. Now, each of our turbines in our area are about a kilowatt of energy per hour, which is enough to power all sorts of energy. I'm sorry, not a kilowatt per hour. A megawatt, much larger. Our solar panels up top are only a kilowatt, a megawatt. So a lot of energy being produced by all these wind turbines. What's the problem? So we have large farms like we have. You could have individual turbines, small ones for your own house, which I've considered doing actually. But the problem is that the wind doesn't always blow. And so if it always doesn't blow, then sometimes it's just sitting there. Now, Illinois is a major wind producing state. And so that's why they're coming here with these turbines and putting them in. It truly does work on a better scale if it is smaller. If we look at this diagram, this is a 2014 diagram. It's the only one I could find from USGS, so I apologize. But if you look, these are all the wind farms that are located in the United States. Well, then all of a sudden you go, well, wait a minute. Why is it that every state doesn't have it? And what you see here is there's a big void right here through Virginia, Tennessee, Arkansas, bottom of Missouri, into Texas, back down to Florida, and around back. What's the problem? Well, in this area, there's lots of hills, and so you can't do anything with it. But then down here, this is all sand, and so if you put a wind tower in, and the wind blows, it would just blow it over because there's nothing to secure it to. And so there's different reasons why these areas don't have wind turbines, but these areas are not really conducive. But where we're at, this area, Iowa, Illinois, Indiana, oh yeah, we are producing quite a bit of wind energy. Okay, so what I want you to do is two things. I want you to go ahead and you're going to push stop. You're going to watch the wind power video on your Moodle. And then when you're done, I want you to work on your review. And then we have some other things for you to do. So I can't say how proud I am enough of you guys. You guys do a great job, and a lot of times, you don't hear it. And so I want to tell you, you guys are awesome. Thank you so much for being amazing students and amazing kids, and I appreciate everything you do. So hope you have a great day. I wish I was there with you, and I'll talk to you when I get back. Thanks.